Hello students, how are you? Today, we will continue our learning session on the topic of light. And especially through this video, we will learn about the reflection of light and the formation of image in a mirror. As you already know, one of the light properties is that light can be reflected by any object that is exposed to light. The reflection of light simply is the process of re-emitting light after it hits an object. One of our daily activities which shows this phenomenon is when we look into the mirror. A mirror is one of the objects which reflects light. When we see a mirror, the light that is our face or our body is reflected by the surface of a mirror, so we can see a picture of ourselves in a mirror. The picture that we see is called an image, and the process of producing it is called the formation of an image. In general, there are three types of mirrors, which we are going to learn in today's video. They are plane mirror, concave mirror, and convex mirror. Let's study the reflection of light and the formation of image on each of these mirror types. Plane mirror. A plane mirror is a mirror in which its reflective surface is flat. We see plane mirrors very often, and in fact we use them in our daily activities. There is a law known as Snell's law. This law stated that first, normal line, incident rays, and reflected rays are on one flat surface. Second, the angle of the incident ray and the angle of reflection ray have the same magnitude. This law can be applied to the formation of image on a plane mirror. How does it work? First of all, let's draw a principal axis, a horizontal line. Then, let's draw a vertical line as a plane mirror. The left side is the front side, and the right side is the back side of the mirror. Please give some shading as a sign that shows the back side of the mirror. Next, let's draw an object. For example, let's draw an arrow facing upwards. Then, let's draw the incident rays. To make it easier, we will draw it from the top of the object. The first incident ray is the incident ray which is parallel to the principal axis, represented in red line. Because it is parallel to the principal axis, the angle formed by the first incident ray is 0. So, the angle of reflection ray will be also 0. Let's draw the reflected ray represented by a green line. The second incident ray is an incident ray which forms an angle to the principal axis. For example, the incident ray forms an angle of magnitude theta. According to Snell's law, we will also form a reflected ray with a magnitude theta. Let's draw it. An image is formed when there is an intersection between two reflected rays. Let's extend every reflected light we drew earlier to the back side of the mirror. Let's draw it as the dotted lines. After we extend the two reflected rays, then we can find the point of intersection between these two lines. That's where we get the image. The properties of the image formed in plane mirror are: first, it is a virtual image. Second, the distance from the image to the mirror is the same as the distance from the object to the mirror. Third, the height of the image or the size of the image formed is the same as the height or the size of the original object. The last one is the image form is upright. After we try to reflect light and form an image on a plane mirror, there are several other things we can do from a plane mirror. First, we can calculate how tall the mirror is needed so that we can see all parts of our body. In other words, we can find a minimum mirror height so that the image of our entire body is formed in the mirror. The formula is y equals half times h, where y is the height of the mirror and h is the height of the body. Next, we can count how many images are formed when two plane mirrors are facing each other with a certain angle. The formula is n equals 360 per alpha minus 1, where n is the number of image formed and alpha is the angle between two mirrors. Let's try to do these exercises. The second type of mirror is a concave mirror. A concave mirror is a curved mirror with a shiny coating or its reflective surface is on the inside. Concave mirrors can be found in everyday life, such as dressing mirrors, parabola, and astronomical telescopes. Here is a diagram explaining the concave mirror and its parts. O is the center of curvature. F is the focal length or focal point of a mirror. R is the radius of curvature. Notice that R equals 2 times F, so F is the half distance of R. The properties of concave mirror. The incident rays will always be reflected through the focal point, so the reflected light will be collected and diffused. This is called as convergent light. Then, the focal point is located in front of the mirror, so the value of focus or the value of focal point is always positive. Three types of light that can be applied to the concave mirror. First, incident ray that parallels to the principal axis is reflected through the focal point F. Next is the incident ray passing through the focal point F, reflected parallel to the principal axis. The third one is incident ray passing through radius of curvature R, reflected through also the same point. Concave mirror can be divided into separate rooms. Room number 1 is the room that lies between points O and F. Room number 2 is the room that lies between points R, F, and R. Room number 3 is the room located in front of point R. And room number 4 is the room located behind the concave mirror. There are several things you can remember regarding this room division. First, the place of image or the room number of image plus the room number of the object equals 5. If the place of the image is bigger than the place of the object, you will get a magnified image. Meanwhile, if the place of the image is smaller than the place of the object, you will get a diminished image. The properties of the image that is formed from the reflection of light in a concave mirror are given in the following slides. There are several formulas used in a concave mirror. First, a formula to determine the magnification of an image. The formula is M equals absolute number of di per do equals absolute number of hi per ho. where M is the magnification of an image, DI is the distance of image to the mirror, DO is the distance of object to the mirror, HI is the height of the image, and HO is the height of the object. The second formula is to determine the focal length of a mirror. The formula is 1 per f equals 1 per DO plus 1 per DI, where f is the focal length of a mirror. Let's try to do this exercise. The last type of mirror is the convex mirror. Have you seen this item before? Yes, it is a convex mirror. Convex mirror is a curved mirror with a shiny coating, or its reflective surface is on the outside. Here is a diagram of a convex mirror. The properties of convex mirror is this. The incident ray in the convex mirror will always be reflected as if through a focal point. Thus, the reflected light will be scattered or spread out. This is called divergent light. You will notice that the focal point of convex mirror is located behind the mirror, so the value of focal length is always negative. Three types of light that apply to the reflection of light in a convex mirror. First, incident ray parallel to the principal axis is reflected as if it is from the local focal point F. Second, incident ray passing to the focal point is reflected as if it is to the principal axis. The last one is the incident ray passing to the radius of curvature R is reflected as if it is from the same point. There are several formulas used in convex mirror. The first one is the same with the magnification formula in the concave mirror. The second one is also the same with the focal length formula used in concave mirror, but you will notice that the value of focal length in convex mirror is always negative. The properties of image formed in convex mirror are always a virtual image, upright image, and diminished image. The usage of convex mirror you can find in car mirror, traffic mirror, blind spot mirror in supermarket, and lamp reflector. Let's try to do this exercise. That's all for today's video. I hope you guys enjoyed our physics learning from this video. See you, good luck, and God bless you.